Hello everybody, sorry for the surprise absences, it surprised me too. A little health problem popped up with a member of my family, so I'm at home taking care of that. I should be back tomorrow though. But anyway, time waits for no one, so let us move on. So I've got two triangles here. One of them is labeled correctly in terms of the lengths, and one of them is not. The angles are correct for all of these. So this is 98 degrees and 98 degrees and so on. But one of these is correct with the side lengths, one is not. I'd like you to pause the video for a second, think about it, justify why you think one of these is right, A or B, and then unpause, and we'll talk about it. So the big idea here is we can tell by looking that this is the longest side. So A must be correct. But the big learning takeaway is we see this is the longest side and it's opposite the largest angle. And if we extend this, the smallest angle, ooh, that's a terrible color. Let's try green. The smallest angle is opposite the smallest side. And the one in between is opposite the one that's in between. So triangles have this interesting relationship built into them that the size of an angle in some way affects the length of the opposite side. It doesn't tell us anything about the adjacent side or anything like that, but that the opposite side has to be the biggest. And that makes sense for what we know about right triangles, right? Because a right triangle will always have one angle be 90 degrees, and all of the triangle's angles have to add up to 180. So that means if that's angle A and that's angle B, well, A plus B have to add up to 90 as well, because 90 plus 90 is 180 degrees. So they both have to be smaller than 90. So C will always be the biggest angle in a right angle triangle, and the hypotenuse is always the longest side of a right angle triangle. So we took something we know about right angle triangles, and we're kind of extending how that works into ones that are no longer right angle triangles. Because really, that's where we're going with this batch of trig, is what if it's not a right triangle? We don't just get to give up and go home anymore. We've got some new skills to learn. So let's do an examination right here. So I've given you three triangles, X, Y, and Z. And you're going to complete this table. I'll walk through the first level of the table with you, and then pause the video, and I'll complete everything so you don't have to watch me waste time doing that. And away we go. So I need to find sine of A for triangle X. So sine of 82 degrees. So to the handy dandy calculator. Sine of 82 degrees. Make sure my calculator's in degree mode. Always a good reminder. Make sure you are in degree mode. Not RAD, not GRAD, DEG. And if you're not, there should be a button that says DRG or DEG RAD GRAD that'll switch. So if I look up the sine of 82 degrees, I get, let's do our 4 decimal places like usual, 0. Ooh, what's going on there? Try that again. 0.9903. Well, they're bouncing all over the place. Alright. For B, is 59.4 degrees. So sine of 59.4 degrees is 0.8607. I do not understand what is happening right now, but here we go. What else is new with tech in this course, eh? C is 43.1 degrees, so sine of 43.1 degrees, I get 0.6833. Oh, very strange. Every time I erase, it moves. Every time I do anything, it moves down. Alright. And then it says, we're going to do, remember, read the ratios. Two numbers divided by each other. So the ratio of side A over the sine of angle A. So if you remember how triangles are labeled, if angle A is at the top, side A is opposite it. Side B is opposite angle B, and side C is opposite angle C. So we're going to be comparing the length of a side with the sine of the opposite angle. So A is, so this will be 29. Alright, we gotta figure out what's going on here. I'm going to pause and I'll be right back. Okay, figured it out. So I want to do A divided by the sine of A. So I have the sine of A here, and A is 29. So I'm going to do 29 divided by 0.9903. 29 divided by 0.9903. And I get, let's do one decimal place, 29.3. Similar for B, so this will be 24 divided by the sine of B, which was 0.8181. 24 divided by 0.8181. That's 29.3. And then for C, side C is 20. This is going to be 20 divided by the sine of C, which was 0.6833. 20 divided by 0.6833. And that gets us about 29.3. So I'll pause it here. You might think you figured out the pattern already. Good for you if you have, but one line doesn't make a pattern by itself. So let's do Y and Z and see if our theory remains strong, and then unpause the video. Alright, there's the completed table. So one thing we had to do was we weren't given this final angle for B, so we remember all the angles in the triangle add up to 180 degrees. So we took 180 and we subtracted the other two angles, and whatever left was angle B, and then we could use that. So we seem to have a pretty consistent pattern going here for a triangle X. The ratio of A over sine A is the same as B over sine B, is the same as C over sine C, and that's also the case for Y, that's also the case for Z. So that's a pretty strong case that we've got here, that for any triangle, the ratio of side over sine of the opposite angle is the same for all sides. And that sounds like a math theorem, and sure enough, that's our theorem. It's called the Sine Law, or the Law of Sines, depending on how fancy you want to sound. So if we have any triangle, and we just write triangles like this, so we know that it's a triangle. So whatever the three corners are named, we write them in order, and we write a little triangle in front of it. So for any triangle, we can use the following ratios to solve with proportions. So we have A over sine A is B over sine B, which is the same as C over sine C. We can also write it upside down, but we'll ignore that for today, and we'll worry about that tomorrow. And one thing to remember is when we're solving with a ratio, solving with proportion, we need two ratios where we know 3 of the values and we have 1 unknown. So you would never have all 3 of them. We might use this one and this one, or the first one and the third one, or the second one and the third one, but never all 3 at the same time. If you try and use all 3 at the same time, you're going to get yourself into a mess. You have multiple equal signs. We don't know how to solve it, so we just pick the 2 that work. So let's take a minute here again. How do we know if we can use sine law? Well, since it's a proportion, we have to create pairs of sides and opposite angles. So what that means is we need one pair of side and opposite angle where we know them both, and we need one pair of side and opposite angle. So the first one was where we know both of them. And we need one where we know one of them and the other is what we are solving for. That was weird, I thought. I have a much better way to demonstrate this in the next example, but that's still good to have as a backup. So I want you to, again, pause the video, take a minute, look at these 4 triangles, and based on what we said, we need to look at having angles and opposite sides where we know both of them, or we know one and the other one is what we're solving for. So we need one where we know both, and one where we know one and the other is our variable. So pause, take a minute, go through these 4 and see which ones you think we can solve with sine law. Alright, so welcome back. Hopefully you took the time to try it yourself. It's really, really important to try things yourself. You'll learn a lot more that way. So let's look at, I call this the loops. The loops method. So I'm going to do a blue loop for one that I know both. And I'm going to do a red loop for when I know one. And I have the unknown, the thing we're solving for. So if I can draw both of those loops, then I can solve it with sine law. If you don't have 2 colors, you can do the same idea with the 2 loops. So for A, so remember, they have to be an angle in the opposite side. So there is my I know one and I have my unknown. So that's the second loop. Can I make the first loop? Well, some of you might want to do this and say yes, but this isn't an angle and the opposite side. These are both sides, right? So that doesn't work. It has to be, a loop has to be a side and the opposite angle. So this angle and side go together, but I don't know the angle. So I don't have that loop. This angle goes with this side, but I don't know the angle. So I can't draw that loop. So since I can't draw that loop, well, let's not very good writing, then we can't solve it with sine law. That'll be next spiral. We'll learn how to solve that one. So that one's no. Second one here, and again, if that makes sense where you didn't understand before, try the other three with the loop method, pause it, and then we'll keep going. All right, so this one. So I have an angle and the opposite side. So there's my blue loop. Can I do my red loop? Well, this angle is opposite that side, and that has one thing I know and my unknown. So that is both things I need. We can solve with sine law. Next, we have C. We have, let's see, this side is opposite that angle, and I know both. So there's my first loop. Can I get the second one? Well, here, those are opposite each other, angle side. One I know, one I don't know. So I have 1, 2, 3 things I know, one that I don't. We can solve this with sine law. We're not going to do today. We'll do that type tomorrow, but we can solve it with sine law. We just don't know how to do that type yet. We're just going to solve sides today, but that is solvable by sine law. And then D. Well, if I try and do that, I only know one of the two things in the loop. If I do that, well, I only know one of the two things in the loop. And if I try and do that, well, I only know one of the two things in the loop. So I can't do either loop. So this one cannot be solved by sine law either. So this one said, solve for all of them. We're not going to. We're just going to solve for B. Alright. So let's draw, let's snip that. Get another copy of it so we can see. We got a little extra scribble there, but that's fine. Alright. So we set up our two loops. We just need to set up our proportion now. So let's start by labeling. Labeling is never a bad idea. So it doesn't matter what's what. So I'm just going to do A, B, C. So A is opposite A, B is opposite B, C is opposite C. So this time I'm dealing with angle B inside B and angle A inside A. So I'm going to use the first two ratios from our proportion. So that means I'm going to use A over sine A is equal to B over sine B. And we'll substitute in all our values. So A is 7. So 7 over sine of 60 degrees is equal to x over the sine of 80 degrees. And then here's our good old proportion method. Z pattern or rule of 3. Z pattern, we go back, back, back. And x is equal to 7 times sine of 80 degrees over the sine of 60 degrees. Or if you like rule of 3, you can do it that way. These two are next to the x, so they multiply and the opposite one divides. So x is equal to 7 times sine 80 over sine 60. So it's the same either way, as it should be. And we can do that on our calculator. This is one that you're going to have to practice. If you have a calculator that does it in order, it's really easy. If you have one that does it out of order, it's really annoying. You have to do 7 times 80 sine divided by 60 sine. But you can still do it all in one step, so do not calculate them ahead of time and round. You'll get errors. So keep it all in one go. So 7 times the sine of 80 divided by the sine of 60. Make sure we're in degree mode. Gives me 7.96. We don't have units. So that's the answer. X is equal to 7.96. And that's it for today. Try the practice problems, and hopefully I'll see you tomorrow. Take care.